Good day, tutor. My name is Daryl, and today I'll be presenting my Excel implementation and mathematical analysis for scenario 2 of the EM1 assignment. Per the assignment's instructions, I will be skipping the explanations for question 1 through 3 and focusing entirely on the analytical solutions in question 4 and the curve fitting methodology in question 5. Starting with question 4a, we are asked to evaluate the x-intercept of our quadratic function dynamically using our start inputs where a equals to 2, b equals to 3, and c equals to -1. To achieve this, I implemented the quadratic formula directly into the Excel. So, as you can see, you can see the formula here. It is Moving on to 4b, the objective is to transform the standard form equation into the vertex from layout y equals to a bracket x plus m bracket square plus n. To make this completely dynamic, I use the algebraic principle of completing the square. In the first highlighted cell, I linked it directly to our leading coefficient a by referencing it to cell G4. For the second component, m, the mathematical translation is b divided by 2a. In Excel, I have written it as I4 divided by 2 times G4, calculating a value of 0.75. Finally, for the vertical shift component n, the mathematical formula is c minus b squared over 4a. My Excel tracks this using K4 minus I4 squared over 4 times G4, resulting in negative 2.125. Together, these cells dynamically output the exact vertex equation displayed in our worksheet hint. For question 5, we are shifting our focus to the real-world curve fitting using the photograph of a water fountain stream in the image. For question 5, we shift our focus to real-world curve fitting using the photograph of a water fountain stream as our target blue curve. In part A, analyzing this graph through trial and error gives us significant insights into how the quadratic coefficient manipulate the parabola. Because the water fountain stream arches downwards, our current positive value of A must be changed to a negative value to invert the curve. Furthermore, to widen the parabola so it spans across the fountain's trajectory, the magnitude of A must be brought closer to 0. From there, adjusting B shifts our axis of symmetry left or right, and changing C shifts the maximum height up or down. Now for question 5b, to transition from trial and error to a truly rigorous mathematical approach in 5b, we can utilize a system of linear equations. By identifying three highly accurate coordinates x and y along the targeted blue fountain curve, we can substitute them into the general quadratic equation y equals to ax squared plus bx plus c. This provides us with three distinct linear equations. By setting up these equations into a matrix format in Excel, we can use the inverse and mmult functions to multiply the inverse matrix of our x value by the matrix of our y value. This computes the definitive mathematical optimized coefficient for A, B, and C, allowing our generated orange curve to perfectly match the physical path of the water fountain. Thank you very much for your time. This is the conclusion for my video.